So recording up there in the upper left corner. And we will resume with some things that will generate errors. So if you auto configure having sensors without motors, motors without sensors, excuse me, will generate an error. This would be part of, if we could consider expected results and what to do if things go wrong.
Mm-hmm.
An expected result is after auto configure, you put a load in front of your first sensor, it goes down the conveyor and falls off the end.
Okay.
That's expected. Well, then you have what to do if things go wrong. I always like to say, follow the box. Put a box in front of the first photo eye, go to where it stops.
Okay.
That's where your issue is. It could be a motor without a sensor without a motor, a misaligned photo eye, an Ethernet cable wasn't plugged in all the way, etc. Basic troubleshooting.
Okay.
Whatever the issue, whatever you find the issue to be, correct it and perform auto configure again.
Okay.
Rotational definition. By default, looking at the cable end of the motor clockwise is the default direction, meaning left to right. So if you have like one section of conveyor with one card and you want to just span the space between two pieces of equipment, by default, that one card is going to move the loads clockwise. So make sure you mount your conveyor in the correct orientation.
Okay.
The procedure before you begin. You want to make sure all the cards are powered up. All of your sensors and motors are connected. Make sure your sensors are properly aligned. Auto configure expects a clear conveyor when you perform the procedure. And all your Ethernet cables are connected. It is best to not have a PLC connected at the time of auto configure. PLCs, especially if there's programming inside that says talk to an IP address, and it ends up being one of the cards, all that extra traffic can possibly interfere with the auto configure procedure. So just make sure you don't have a PLC connected at the time.
Okay.
Also, other devices. This right here is okay after auto configure. So during auto configure, you want to do this. Connect the models directly. After auto configure, then you could put a switch in here and add a scanner, a VFD, an HMI, etc.
Okay.
But not during auto configure.
Does auto configure set the IP address downstream? I mean, after
Yes.
you
Yes and no.
Okay.
Yes, it's part of here's the procedure. Well, the procedure, and we'll go ahead and basically it's press and hold after you've, all your conditions are ready. You press and hold the install button. In approximately 5 seconds, the module status LED will start flashing red. Release the button. It'll do its thing. When it completes, all the CPUs will reset, and it'll power up and be ready to go. So we'll go ahead and watch the video, but also keep in mind that with the current firmware that's shipping on the cards, which is the newer firmware, you can use Easy Roll Plus software to perform auto configure. But this is doing it manually. And that is pretty much it. If you was to use the new software, for example, as well, mouse. It would be discover, topology, and auto configure. You would then select the modules you want to be in your network. Select which card is going to be node 1. And you could either say auto configure and use this IP address schematic, or you can right click and select change IP and auto configure. And here's where you could select, what IP addressing you want and masking you want the modules to have.
Mm-hmm.
This right here is all factory default, but we could make this one our 160 network. I want to leave this factory mask because that's how my PLC is set up, so it'll make it easier later. And all we would have to do right now is just press change IP and auto configure. This lets us know when it completes, it's going to do the product search. And what that means is it'll start up and it'll look for loads stranded between photo eyes.
Okay.
So we say yes. As you can see, these are both 202.20. When it completes, we're going to have a 160.20 and a 160.21.
So, and that's used for.
While this is taking place, I'll kind of explain everything that happens during auto configure. So one, you select your module, which end of your conveyor. And now you can hear, I don't know if you can hear the motors running behind you, but that's the startup procedure. And here you can see our new IP address, 160. Here's the plus button.
Okay.
So we can see 160 and 160.20 and 160.21.
Gotcha.
So when you perform auto configure, you're going to select your node 1, and you may or may not change the IP address and subnet mask. It may be okay to use the factory default settings. But let's say you change it like I did. And I said auto config from here. What happens is first, and this happens also if you do it by pressing the button. The same thing occurs, you just trigger it a different way.
Mm-hmm.
First, the card will determine, can I be node 1? And it does that by looking on the Ethernet ports. Do I have a connection on my left port? Yes. Do I have a connection on my right port? Yes. Well, that means I'm in the middle and I can't be node 1. Abort procedure. Then it says, okay, initiate auto configure. Look at my left port. Do I have a connection? No. Look at my right port. Do I have a connection? Yes. That tells us two things. Number one, yes, I can be node 1. And number 2, my direction of flow is left to right. Simply by just not having an Ethernet cable on the left port. I'm node 1, and my flow is left to right.
Okay, so no one left port is not connected to a PLC at this moment because we're doing the auto configure.
Yes.
So leave that port dry if you want it to be node 1 left to right.
And then the same thing happens on the other end. For example, we initiate auto configure.
Mm-hmm.
Do I have a connection on my right port? No. Do I have connection on my left port? Yes.
Okay.
that says, yes, I can be node 1, but my flow is now right to left.
Okay. Gotcha.
The next thing it'll do is the IP address. It'll keep the first 3 octets, 192.168.60. Node 1, the first card, will always become .20. And for now, that cannot be changed. That's just the way it is for now.
.20 is the starting point.
Correct. Next, it looks at the subnet mask and it keeps it. Next, node 1 generates a random number. We call that the configuration ID. Lastly, node 1 sets a bit in a register that says first flag on the first module. Once it does that, it passes the data to the next card. The next card looks at the IP address. It increments the 4th octet by 1. Thus, I became 21. I keep the subnet mask. I keep the configuration ID. Then I look at my right port. Do I have another connection? If I had another connection, it would pass the data. The next card would become .22. Pass the data. It could, it could go all the way as high as .220, as high as .240. A total of 221 modules could possibly be in this network. But in our case, it's just 2. So node 1 passes the data. Node 2 increments the octet to 21, keeps the ID number. Do I have a connection on my right port? No. That means I'm the last card in the network. Set a bit, the last flag, the last bit. Now our network is properly auto-configured. We have incrementing IP addresses, the same subnet mask, the same configuration ID, a first flag and a last flag. And now because we also have a procedure called auto replacement. When you perform an auto replacement, it checks a couple of those items. Number 1, it will check configuration ID numbers, and then it checks for the first and last flags. So let's say when you have, for example, this is the last card in the network. It only has one neighbor. It doesn't have another one. So it will accept any data node 1 gives it. This is, and again, the same way, because this is only 2 cards, and we want to replace this card, it'll accept any data this card gives it. The exception now comes when you have a lot of cards. So let's say there's 3 cards, and there's another card right here. You initiate auto configure. Before it will even begin, the first thing that this new card does, it'll say .20, what's your configuration ID number? It'll say .22, what is your configuration ID number? And if they don't match, it will abort the process, because the new card does not know which card on the conveyor actually has the correct information. Now, wait a minute, Tim. You just said when you auto configure, node 1 gives everybody the same configuration ID number. So how could, when I auto replace, how could there be different configuration numbers on the conveyor? That usually happens when integrators use system backups from other networks or other systems. Those other networks and other systems are going to have different configuration ID numbers. And because those numbers are different, auto replace will not work. Well, why would someone do that in a hurry? Well, I know at the last job, I had all these working right, and this is exactly the same except for maybe some IP address stuff. So I'll change the IP address on this card. I'll load the backup to get all the right settings and then change the IP address back. Okay, yes, you put good settings on the card, but you put the wrong ID number on the card. And now auto replace will not work.
Oh.
And this information that I'm telling you is the exact same information I tell every integrator that comes to training. So if it, I'm not saying everybody comes to training, but when you come to training, you learn this right here. These are things that will keep this capability from occurring.
Mm-hmm.
And some examples. So if we auto configure from this end of the conveyor, our flow is this way, left to right. Notice how left sides are upstream and the right sides are downstream.
Yep.
If we auto configure from this model, when it completes, our flow is right to left. And now the right sides are upstream and the left sides are downstream because of the flow. And this little special case here, this is more, integrator stuff. You get to the job site and someone forgot to put this big column on the drawing. You could leave this card behind the column, but that's really going to make the maintenance guys mad if they have to fix it or replace it.
Yeah, right.
Yeah. So the best thing is to put it on this side.
Okay.
You can leave your motors here. You don't have to take your motors out and redo the whole conveyor. It may require an extension cable to make the cable long enough.
Right.
But what will happen when you auto configure from here, when this right port sees a connection to another right port, this card knows in relationship to the flow of the conveyor, I need to run my motors the opposite way. So where these card settings would say motor direction clockwise, when you look at this card, it'll say motor direction counterclockwise. And the loads will still continue this way. And this card knows how to automatically adjust that because of the Ethernet port connections. Okay. So the cards are pretty smart. Again, our expected results, flashing green LEDs, and we put a box in the conveyor, goes to the end and falls off.
Mm-hmm.
So that's kind of the basics of the product, assigning an IP address and auto configuring. Next, we get into all the default modes of operation. Did you want to discuss these?
Mm-hmm.
Okay. Singulation release. So here's our conveyor. It's stopped. When the conveyor releases, load 1 starts to move. Load 2 remains stationary. When load 1 clears the sensor, that's when load 2 releases. Singulation. Upstream waits for downstream to be clear before releasing.
Mm.
Flex zone. Let's say you have a load that's extra long. Most of your loads are this size, but occasionally you have a load this size. Well, this load is so big, it takes up 2 zones, and it blocks 2 sensors. By default, flex zone recognition is on, and it is enabled network-wide or disabled network-wide. You cannot pick and choose cards.
Mm.
And what happens is this load was moving along. So now we're just at this currently at a stop state. So this load is blocking both sensors. The cards know this. If we looked in the software and looked at this module where photo I3 is, the word flex would be written over the top of that sensor, letting us know that this is in flex zone. And what happens when zone 2 turns on to release, zone 3 also turns on. It moves it as one big load. So zone 2 doesn't have to drag it. If this zone 3 will actually run this as a double length load. Notice how the sensor clears, but this load did not release. Tim, you said in singulation, when downstream is clear, upstream releases.
Mm-hmm.
Normally does. But because this is flex zone, blocks two sensors, photo I3 has to wait for the next two sensors to become blocked, to become out of flex, considered clear, and then the next load will release. If this, let's say this is the very last zone, once this eye clears, this zone will come out of flex. So it will not booger up your whole conveyor. Once the very last sensor completely clears, he goes back to normal functionality.
Gotcha.
The jam conditions, we talked about these already.
Mm-hmm.
Sensor jam, it's when the sensor remains blocked during release. An arrival jam, zones want a confirmation the load made it somewhere after release. Hardwired interlocks. Upstream interlock, zone 1. Energizing pin 4 will wake up this zone to accept this load. When not to use pin 4 as a wake up. An example is, let's say here's conveyor, and this load has tracking data, and you want to pass that tracking data to our cards.
Mm-hmm.
Instead of using pin 4, you use a command from the PLC. Step 1, the PLC would write the tracking data in a register. Step 2, the PLC would then issue the wake up command. When this zone blocks this photo eye,
Mm-hmm.
it'll grab the tracking data, attach it to this load, and move it along the conveyor with the load. If this load had tracking data and you used pin 4 and said wake up, the load would get to the eye. It wouldn't, the card wouldn't look at the tracking data and just keep going.
Okay, wait. So what mode are we in? ZPA or PLC?
We're still in ZPA mode, yes.
So ZPA mode, if I set pin 4 is wake up, and I got tracking data.
The card will reject it.
Okay.
But if the PLC gives a wake up command, the load would accept the tracking data.
And tracking data is a dent?
Yes, it's 32 bits of information, yes.
Okay. And that's ZPA mode.
Correct.
Pin 4 is the wake up.
Yes.
Pin 3 is, and ZPA was zero pressure.
ZPA is zero pressure accumulation, and
Uh-huh.
pin 3 equals force accumulation.
Force accumulation. Okay.
Downstream interlocking. So in the most downstream zone, if we put in a lane full photo eye, this load will arrive and accumulate because lane is full.
Great.
When the lane clears, the last zone will release. So this could be like, example, a gravity conveyor or something like that. Put your wake up eye in, plug it into the control port, and if it remains blocked, we accumulate on the conveyor. When the lane full clears, we release from the conveyor. Local, accumulate, pin 3. Any place or any zone where you energize pin 3, that zone will accumulate. Stop here. Force accumulate.
Mm-hmm.
And we touched on this one. Interlocks with single zone module. And again, that's a module with one sensor and one or two motors. The side with the sensor is always upstream.
Mm-hmm.
And interlock versus accumulate. Now, this would be considered on the very last zone down when we release. If you use pin 4, that's lane full. That's interlocking. Your load would release. It would block that lane full photo eye. That's the confirmation. And if the next load arrives, it'll just release as long as lane full is clear. But if you use pin 3, so you turn on pin 3 and accumulate the load here.
Mm-hmm.
Downstream becomes clear. I turn off pin 3. The load releases. The next load arrives. First, this zone's going to wait for confirmation arrival. It's never going to get it because there's no interlock down here.
Mm-hmm.
So this zone first has, now these are default values. Well, the default jam time is 5 seconds. So this new load first waits 5 seconds for the confirmation. Well, it doesn't get it. Then it waits 5 more seconds to automatically clear that error. And when it does, then this load releases. The next load arrives. Well, it has to wait 10 seconds and then it can release. But if you use pin 4,
Mm-hmm.
every time a load releases and blocks that sensor, that's the confirmation the load made it somewhere. So loads would just continuously keep releasing. There would be no 10-second delay between the loads. Does that make sense?
Mm-hmm.
Okay. Using a photo eye for wake up. Using a photo eye for lane full. This applies to both of them. If you're going to plug a photo eye into the control port, which is perfectly fine, be sure that the photo eye only has 3 wires: hot, common, and sensor signal. If you buy your photo eyes from us, we only sell 3-wire photo eyes.
Okay.
Here's why. If a photo eye has a health signal, that's on pin 3. But in the control port, pin 3 means accumulate.
Mm-hmm.
So if you're so let's say we're doing a wake up and we block the wake up eye and the zone wakes up. But because your wake up photo eye is slightly out of alignment and the health signal's on, well, that turns on pin 3. Pin 3 means force accumulate. So the load would arrive and then just sit there because your wake up eye is misaligned.
Mm-hmm.
So that's why when you use sensors for wake up or lane full, be sure it's only a 3-wire sensor.
It's not required.
The little breakout board, it's called the module itself is called the SE module. When you buy it with the cable, it's called an SE-kit. The card and the cable. That's what most people buy, the kit. And you would just connect the board to the control port. And now, as you can see, we have removable 3-terminal connectors, so ease of wiring. And pin 4 is an input. And if your input's coming from either a PLC or someone else's equipment, be sure to tie your DC commons together. Otherwise, you're going to have to isolate with relays. We prefer tie directly to us. Tie our DC commons together, makes it simple. And this is for both pins 3 or 4. If you're doing syncing, NPN, still tie your DC commons together. If the output from our card is going to your PLC, again, be sure to tie your DC commons together. We saw earlier by the schematic of the sensors, or I'm sorry, where was that? Internal fusing. Each side only has 100 milliamps available. Well, let's say we need a power device. Well, first we got to consider we have a photowatt plugged in. Well, that's about 10 milliamps. So now we only have 90 left. But this device requires 250, quarter amp. If we turn it on, we're going to shut down. We're going to overheat that fuse and shut down that side of the card. So what you would do is, and this is usually right from your power distribution, add 24 volts to the 24 volt terminal. There's a diode that keeps this from backfeeding to the card. And when you turn on the output, it will draw through here. And you can power a device up to 500 milliamps.
Okay.
Which is usually strong enough for almost anything nowadays. Automatic module replacement. There are 3 things that must be true before auto replace will work. Number 1, you must have performed an auto configure. Number 2, you cannot manually change the IP address of a card after auto configure. 3, the way the Ethernet cables were connected, you can't change that. Now, we did show up here that after auto configure, you could add this switch. But, during your auto configure, don't have that switch. Make it like this.
Okay.
As long as these 3 conditions are met, you can you take your old card off the conveyor. You put your new card on the conveyor. You connect everything but power. Now here's the manual. This is the manual way. Example, physically manual, like a maintenance personnel would do. They take the new card, put it on the conveyor, connect all the motors and sensors and Ethernet cables. Press the install button and hold it in. Then apply power. When the card powers up with the button pressed, that tells the card initiate auto replace. And then it will start talking. Okay, what's your ID number? What's your ID number? Okay, they match. Okay, so because there's 2 ID numbers, I'm in the middle, so I got to find first and last flags. Okay, give me an IP address. Auto replace will also put the correct firmware on the card. So give me the correct firmware. Now give me all my settings. Now I'm ready to go.
Gotcha.
The other way is to put the module on the conveyor, press discover. And for example, because this is the 160 network, it would be easy to find the module because it would say 202.20, the default IP address. And you would select topology, yes. And let's say this is the brand new card.
Mm-hmm.
Right click, replace.
Mm.
And it's that simple.
Okay, so it's probably easier with software to do a replacement.
If it's available. But the buttons were the first part of the original design, which means it was this capability was made with the intention of, the maintenance guys not needing a PC, something that could be done without software.
Mm-hmm.
Now, when it comes to, we've talked a few times about PLCs and we've talked about firmware.
Mm-hmm.
That's why it's important to, whenever possible, make sure all of the modules in your network have the exact same firmware.
Very critical.
Because yes, so let's first say, for example, let's say we had 3 cards, and there's a card here, card 3,
Mm-hmm.
and well, card 2 talks to the PLC, and it has firmware 424 on it.
Okay.
This 240. Oh, that was my mistake. Let me do my topology.
Okay.
Okay, I don't know what happened here. I don't know what, but I pressed something wrong there. Connections. There we go. Okay.
So do you have physically 4 modules? The first one is, it's kind of like that option,
Yeah.
like a input.
Oh, because
You say you discontinued it or something, that CNIP.
no wonder.
Can they share?
One second here.
Okay.
I need to fix an issue here. One second. Shoot. Trying to find a file.
Okay.
The most I can't remember which. 1 second. I know what I. 1 second. I'm sorry. I apologize for this
Oh, you ain't
because
bothering me. I'm
because I made a mistake. Here, I'll let you see what I'm doing here. Put this back up here. There we go. Because I can't remember the IP address of that module. Hopefully I didn't do, I may have messed up and created 2 duplicate networks. Oh, it's not in this one.
You could still hear me though, right, Tim?
Yes, sir. Yes,
Okay, I'll just make sure I calm. It's still good.
sir. Desk. Work. Demos. At my desk. There we go. 1620. So yeah, I made a mistake.
Okay.
So let's do this.
Mm-hmm.
Autoconfig. Let's change the IP. We'll make this 185. Completely different.
Okay. You can still hear me though, the Tim, right?
Yes, sir. Yes.
All right.
And I apologize that I did not pay attention that I already had a 160 network.
Oh, that's fine. And if you need to pause this part of the
Oh, no, we'll keep going.
okay.
It's kind of, yes, I made a mistake, but you got to see what I did to figure out what I did wrong.
Gotcha.
I didn't know was this the wrong IP address or did I give this one the wrong? And because I couldn't quickly find a backup with this card in it,
Mm-hmm.
I did go to a program that I had this card in. And because how it was given an IP address in the program, I knew I made a mistake on these. This should be 160. A lot of this has occurred. We kind of transitioned from one set of IP addressing and masking to another with a lot of conveyors and things. So kind of my fault for not keeping up. So now here we go. So we're back. So we are back to normal. So that is auto replacement.
Okay.
Factory defaults. These are all the default settings for a ConveyLinks ERSC module. These are all the main screen settings for EasyRoll 422. You see all the motor settings and zone settings right on that main page. Anything that was in the advanced dialog and you made checkbox settings or change the values of timers and things, those would all be set right back to factory defaults. Checks are unchecked and things like that.
Okay.
This is just a little bit more in-depth information about that breakout board. And one thing that, if you are going to use this with a PLC, the output from us will be okay because it's basically kind of isolated relay style. But our inputs, because we auto detect when it comes to your sourcing or syncing output card, and you connect it to one of our inputs, there's going to be leakage current, and the input will always be on. That's no good.
Okay.
So that's what these little jumpers are. So this says pin 4. This says pin 3. and there's two little jumpers. The jumpers are connected to diodes. So that way, so this right here, so pin 4 is this connection here. This connection is what goes to the card. These are on this board right here. So if your PLC has a PNP output, you would want to remove jumper 1. So that would open up this part of the circuit, and it would force the PLC output to go this way through this diode, a forward bias diode. And what happens is it keeps the electrons from coming back out, creating a closed circuit. It forces the input extra current from the PLC to push the power in, thus completing the circuit.
So you have to remove jumper 1, right?
Yeah. So
if
you have a sourcing PLC, a sourcing output, for pin 4, remove jumper 1, or pin 3, remove jumper 3. So that's what, if you have a syncing, meaning NPN output from your PLC, you would remove jumpers 2 and 4. So that's what this is letting us know, which ones to remove based upon the type of output card the PLC is using.
But to use the breakout board.
Yes, yes. Easy roll. So believe you have Easy Roll installed. Is that correct?
Yeah. I just don't have a module, but I have the software. Let's see which one did I think I got Easy Roll Plus installed right now.
Okay. You would want to, if you was to go to, downloads, software, Easy Roll, here you can get that version 422. And you would want
version
this
I have.
because your system has modules with firmware 4.24 on them.
Now the software revision is 1.2.36.
That's Easy Roll Plus.
Okay. That's the latest firmware that you guys do.
Yeah, so this is the latest software, but unfortunately, because of the firmware on your modules is so old, you want to use this one. Easy Roll. Okay. Regular Easy Roll 422.
Okay.
And so basic definitions, IP addressing. This is just an example of, this is some cards that somebody pulled off the shelf. They have various IP addresses, including duplicate IP addresses. Perfectly fine.
Okay.
When you auto configure, again, we keep the first 3 octets of node 1, make it .20, keep the subnet mask, pass the data, increment the 4th octet, pass the data, increment the 4th octet, pass the data, increment the 4th octet. I'm at 23, but I have no more connections. So stop the process and set last flag.
Gotcha.
And here's our note letting us know that we can go all the way up to 221 modules in one network. Most customers do not do that. They would have a network of 50 cards or 100 cards. It's a little bit easier to manage that way.
Okay. Are you familiar with Rockwell's EN2T?
The EN2T,
Yeah,
that one will probably do about 128 modules.
Okay, from you guys on one network.
Yes.
Which is not recommended, but I'm just saying it.
Yeah, yes. Well, yeah, that will allow up to 100 and it'll say 128 connections. It'll allow you 127.
Let me ask you a question now that we're on that topic right here. If I had 128 cards on that network for that EN2T, God forbid if I do, what is the RPI? I know I talked to tech support and they talked about RPIs kind of cascading.
Yeah, so it kind of depends. So if you do have, a full Ethernet card's full, let's say you did put 128 on there,
Uh-huh.
depending on what they're doing, you could have higher or lower RPI rates, and like, and you could even, instead of what Nick was mentioning about staggering, is instead of, for example, you have 50 cards
Mm-hmm.
and they all have a 10 millisecond RPI rate. Well, that at every 10 milliseconds, the processor is going to try to write data to 50 cards. But
Correct.
if you kind of stagger them a little bit, 10, 12, 14, 16, and then did the next set 10, 12, 14, 16, you're
Uh-huh.
still pretty damn fast on your RPI rates, but you're
So,
not going to try to write every card at the same time.
so so we had 128 cards, right? And then you're saying that let's see what the good multiplier for 128.
I mean, you don't actually have to stagger the RPI rates, but that is something that can be done if you're noticing disconnects.
Yeah. So I was thinking about how many cards? Every 12 cards stagger 'em?
Stagger every 12. You could have 10 cards at 10 milliseconds,
Mm-hmm.
10 cards at 11 or 12,
Mm-hmm.
10 cards at 13, things like that. So just a
Okay.
slight little difference keeps every card from being hit, if you will, at the same time.
But default is 200 milliseconds, but we can poll faster.
That is correct. Actually, what I've noticed with the EDS file, it defaults to 50.
50 RPI.
Yes.
Okay.
And then you can adjust it up or down.
Okay. All right. I got to keep that in mind because we got them stacked on a network, and I don't think we superseded 128 per that EN2T, but we were having comms issues, and it's probably, I think everybody was set on the same default RPI. So the PLC was trying to poll, and I think it was polling every 200 milliseconds and saying, give me updated information, but give me everybody's information at one time.
So since you're already at 200, I'd back down to, like 225. Or I'm saying, you said if you're at 200, yeah, then you get then go 175 for a handful, 150 for a handful.
Right.
Things, yeah.
Okay. All right. I got to keep that in mind because that was some of the networking.
And
then we talked about the disabled keying with the firmware issue. And
that is correct.
I think they had that in motion, and so I haven't gotten any negative feedback from the team, which is at Florida, and that's at that site where they were having issues. But it seems like disabled keying must have worked thus far.
Let me see. I'm looking for something here. Where are you? There you go.
Yeah, he said 200 RPI and most of them massively slow. Task is steady. I think the PLC was on a continuous task scanning at 8 milli, but we have had peaks of almost 16 milli. I believe those peaks are related to the amount of traffic caused by the ERSC card, but he doesn't understand that the staggered RPI would improve communications. So all of them right now was I think they're still default to the same RPI. I think he just disabled keying for the moment.
Okay. Yeah, that would have helped with having newer modules will come with firmware. It's newer. And so, yeah, I would expect you to either have to change firmware or disable key.
Gotcha. All right.
What I opened up here, so if you have Rockwell software, you probably have certain packages. And this is one of the softwares it's called Integrated Architecture Builder. It has a lot of components inside of it. And one of them is this tool right here, the Ethernet Capacity Wizard.
Mm-hmm.
Okay, it's just initializing.
Yeah, it can be slow. I think it always wants to do those updates too constantly. I have an ID on there. I've had to
And what this will allow you to do is select whatever controller you have. So like I have an old L33ER. I don't even know if that's listed in here. Yeah, right here.
1769. So you got
Yep.
the older module with the
Yeah. So mine has embedded
Yep.
Ethernet.
two cones.
Yours you would come down here and you would select
Uh-huh.
your EN2T card.
Uh-huh.
Under IO. You'd hit select IO, so click the settings. You'd start selecting all the devices connected to your PLC.
Uh-huh.
Local user ID, UD. I created this. You can right click on this and you can create your own. And so that's what I did. All I did was import a picture right from our EDS file.
Uh-huh.
And what I did is because an ERSC in PLC mode reads and writes more data than a ZPA mode card,
Uh-huh.
I just said, I'm going to create a PLC mode card. So this is read and write the most data. And then you can set your RPI rates. How many of these do you actually have connected? And you would go through and do that for everything you have connected to the PLC.
Mm-hmm.
And what you would then do is hit compute. And it will tell you if you have any errors. You don't want to see reds. Reds means you're over the limits.
Mm-hmm.
Here it lets me know I'm using 25 modules. I have 7 remaining connections, and everything is well within the limits. So I will have no communications issues with this processor in 25 of my modules.
Mm-hmm.
And so like here it says utilization 26%. Well, if I crank up the RPI rate and compute, now it's 2.6% because I'm not pounding it as hard and as often. So just by changing the RPI rate changes the load on the processor. And so this is a tool. I don't use it all the time, but it is something I will use when customers are experiencing some issues I can't explain.
Correct.
I'll definitely use this as a tool just to see, are you over your limit? And just because you're not over your limit, I mean, a different RPI rate
Uh-huh.
may put you over your limit. Cute. Well, look at that. I added 5 more modules and cranked the RPI rate down to 10.
Ooh.
Now I'm at 62% of utilization for the communications now.
Ooh.
So you can see that was just 5 modules, but cranking down the RPI, wow, now the processor's using most of its time for communications.
And you're polling at the same time, though.
Yes.
But if you staggered, you probably have an improved utilization. Right?
That is correct. So here I could say 15 at 10. Here I could say 15 at 200. And I'm down to the same amount of modules, but because of the different RPIs, I cut the usage in half. Now I'm back down to 32%.
Okay.
So this, I just wanted you to see that there are tools available to also help determine that kind of information.
Okay.
We're at lunchtime now. This is probably a good time to take a little break. We'll come back, and when we come back from lunch, we'll touch on everything. I will use. Let's work with Easy Roll. because I know you have older mods or older firmware that you're probably going to have to deal with for a while.
Okay.
We'll go through that software, and we'll also touch on the new software as well. I don't want to not talk about it.
Okay. And then tomorrow we'll get more into the PLC.
Tomorrow will be all PLC information. Yes.
Okay.
Tomorrow we will start here at the developer's guide. Of course, there's going to be some discussion because of all the ZPA mode, PLC mode, different types of controls are available.
Okay.
And we can usually knock out all of the documentation side right around 10:30 to 11. And then the rest of the day is all PLC examples. This is how you do this. This is how you do that.
Okay. Sounds good.
How long would you like to take for lunch?
We get to 1 o'clock. We'll come back.
Come back at 1 o'clock?
Yeah, that'd be fine.
Okay. Then I'll leave my PC on, of course, but I'm gonna, shut off the mic in the camera, and I'll turn back on at 1 o'clock.
That sounds great.
All right, Taylor, I'll see you in about an hour.
Okay, you don't forget to stop the recording, I guess.
There we go.